has gone missing. We must find him now. Marlin, Dory, and various other creatures set out to find Nemo using several techniques and differentiating characteristics to distinguish him from other clownfish caught by the diver.
Each character is responsible for using one of these techniques to find Nemo. GC is important in identifying the substance based on the strength of intermolecular forces, where longer retention time corresponds to stronger intermolecular forces. The unknown substance has a unique retention time in comparison to other substances as it is composed of different molecules. We use this because it would tell us the retention times of the substance, which would help us understand the strength of individual bonds and its interactions with other molecules and itself.
Dory is tasked with GC, looking at the retention times to identify substances through IMS. This adorable method helps us find when Nemo left home based on his interactions with others. Mass spec is vital for identifying the substance based on the mass of its compound and its ion fragments. It allows us to quantify the amount of elements present in the compound, giving us the molecular formula. We use this technique to find out the molecular formula and to find the chemical identity of the substance.
Marlin's sophisticated father is responsible for MS, looking at differentiating characteristics of molar mass used to identify the molecular structure and weight of the molecule. FTIR is important for identifying the substance based on the type of bonds. By looking at the peaks at different wave numbers, you can determine which bonds are present and which are not, narrowing down the structure and geometry of the substance. We use this technique because it allowed us to determine possible combinations of the components in accordance with the bonds present.
Show ya! Crush and Squirt will be in charge of the FTIR, in which the types of bonds will be the differentiating characteristics to identify the types of bonds present in the substance. We use NMR because it shows us the proton components of all things bonded to an H present, which would help us determine the structure and the groups present. For example, it would show signals indicating hydroxyl, methyl groups, etc. Integration of peaks also allows us to identify neighboring components and figuring out the molecular structure of our unknown.
Mr. Ray specializes in NMR, a very beneficial tool used by all teachers during fish school to identify the H+ proton component of all the fish in the sea. TLC is important as it tells us the number of substances within a mixture. When performing TLC with known substances, one can deduct based on similar spot movements that they are the same substances, while simultaneously allowing us to determine whether it has strong interaction with the mobile or stationary phase.
Bruce, Anchor, and Chem use the strength of interaction forces and performs TLC in detail to show us the number of components in the mixture and finally allow us to know if Nemo is alone or with other clownfish. Each substance has a unique lambda max, so by implementing absorbance spec, we can compare our results with known lambda maxes to identify our unknown substance. It's also important in identifying light matter interactions and absorption of photons by a substance.
These creatures use absorbance spectroscopy to find lambda max, which help us find the specific absorbance wavelength for the substance.
According to our mass spec, the rightmost prevalent peak is at 138 grams. Therefore, it can be implied that this is the molecular weight for our unknown substance.
Our mass spec also shows that there are 4 fragments at 39, 64, 92, and 120.
This allows us to deduct the fact that our substance has 4 main components that have a mass of their respective fragment.
Given the molecular weight and our previous knowledge that our substance can only consist of carbon, hydrogen, and oxygen, we were able to conclude the molecular formula is C7H6O3.
Since FTIR helps us find types of bonds, our spectra showed us that there are CH bonds, C single bonded to C, C double bonded to C, C single bonded to an O, C double bonded to an O, and a peak indicating a possible OH bond.
From this, we can see that there's a carboxyl group and a benzene ring present. According to our NMR spectra, we have a reference point at 7.26 ppm, indicating our solvent chloroform D.
Our first signal to the left is around 10.47 ppm, implying a carboxyl group. Our second signal is around 7.04 ppm, indicating a benzene ring, and our last peak is around the range 0 to 1 ppm, showing the CH component.
Our first signal has only one peak, showing that the carboxyl group has no neighbors.
Our second signal has 2 peaks, showing one neighbor.
Lastly, our rightmost signal has one peak showing no neighbors.
From this it is clear that our unknown consists of a benzene ring, carboxyl group, and a CH group.
For our experiment, we did not use TLC, GC, or AS. We didn't use TLC because we have a pure substance, and since it only shows one dot, it would not be useful in determining the unknown substance. While we did implement GC, it was not useful in determining the pure substance because it only indicated one retention time. We didn't use absorbance spectroscopy because our substance was colorless. Additionally, since we only had one substance, there would only be one lambda max and we would have nothing to compare it to.
Our unknown substance is salicylic acid.
This substance can be found in a white powder form.
It's slightly soluble in water and soluble in ethanol, chloroform D, and ethyl acetate.
Fun fact, it is often a main component in skincare products as it helps clear acne. Fantastic analysis summary.
We found that our molecular weight is 138 grams.
Our molecular formula is C7H6O3.
The types of bonds present are C single bonded to an H, O single bonded to an H, C single bonded to a C, C double bonded to a C, C double bonded to an O, and C single bonded to an O.
Our structures have
get you down, you know what you gotta do?
I don't want to know what you gotta do.
Just keep swimming, just keep swimming, just keep swimming, swimming, swimming. What do? We swim, swim.
Do we know singing?
Oh, oh, oh,